Imagine taking your entire professional livelihood, like your looming client deadlines, your meticulously crafted pixel-perfect designs.
Right, your whole daily workflow, basically.
Yeah, your entire workflow, and just trusting all of it to a single Google Chrome browser tab back in 2016.
Oh, wow, yeah.
Because for anyone working in the industry at that time, that proposition sounded like absolute career suicide. You might as well have been, I don't know, saving your files to a literal cloud in the sky and just hoping it didn't rain.
It was an unimaginable leap of faith. I mean,
Yeah.
we're talking about an era where professional software was completely synonymous with heavy localized desktop applications.
Exactly.
The browser was something you used to read Wikipedia or maybe watch a video.
Yeah.
It was not for rendering complex vector graphics or managing enterprise-scale design systems. Trusting it with your career just felt deeply unnatural.
Unnatural is the perfect word for it. And if you are booting up a design app for the first time today, maybe stepping into your very first role as a graphics or interface designer, you probably take this modern, cloud-based miracle completely for granted.
Oh, absolutely.
You log in, you see your teammates' cursors flying around the screen, everything auto-saves, and it all feels incredibly seamless.
It's like magic now.
It is. But beneath that polished surface lies this wild, incredibly messy history of workflow fragmentation, just sheer frustration, and a massive technological evolution. So consider this deep dive your ultimate shortcut to understanding how we actually got here. We are going to decode the modern design landscape by exploring the pain that actually built it.
Which is honestly an incredibly pragmatic way to approach learning. I mean, when you just memorize keyboard shortcuts without understanding the historical context, like the actual problems those shortcuts were invented to solve, you are basically operating blindly. Understanding the evolution of these tools gives you a profound competitive advantage.
It really does.
It shifts you from being merely an operator of software to a true architect of the whole process.
I love that. Operator to architect. So our guide for this journey today is the foundational text, specifically the introduction to the book Designing in Figma, a masterclass in modern interface design.
Fantastic resource.
Totally. But our mission today goes way beyond just reciting software features. We are going to unpack the intense, almost mind-numbing pain points of early UI design, explore the complex psychology of why professionals resist new technology, and really decode what it actually takes for you to achieve true, undeniable mastery in your craft.
Because the tools we use fundamentally shape the way we think.
Yeah.
If you are designing in an environment that heavily penalizes mistakes or, makes collaboration difficult, your creative output just becomes defensive and isolated. To truly understand modern design methodology, we really have to look at the environment that necessitated its creation.
Okay, let's unpack this. Because to fully appreciate the sheer relief of modern software, and to understand why the author felt compelled to write a literal masterclass on Figma, we have to travel back to 2018.
The dark ages.
Seriously, we have to dive into the specific daily frustrations that drove the author away from what was, at that exact moment, the undisputed heavyweight champion of design software, which was Sketch.
Sketch was an absolute titan. I mean, before we dissect its flaws, we really have to acknowledge its monumental contribution.
Fair enough.
Prior to Sketch, designers were often hacking together user interfaces using Adobe Photoshop. Now, Photoshop, as the name implies, was built for editing raster images, photographs.
Right, editing photos.
Exactly, it manipulated grids of pixels.
Yeah.
But digital interface design requires vectors.
Let's break that down really quickly for someone completely new to this. Like, what is the fundamental difference, and why did it make Photoshop so painful for UI?
So imagine a raster image, like a mosaic made of tiny, colored square tiles. If you try to scale that mosaic up to the size of a billboard, it looks incredibly blocky and blurry because you are literally just stretching those tiny tiles.
Okay.
That's Photoshop.
Right.
A vector, on the other hand, isn't a grid of pixels. It is a mathematical equation.
Just pure math.
Pure math. It tells the computer, draw a line from point A to point B, give it a curve of X, and fill it with the color blue. Because it's just math, you can scale that shape from the size of an Apple Watch screen all the way up to a massive 4K stadium monitor, and it will remain flawlessly razor sharp.
And when you are designing digital products that have to work on, 1,000 different screen sizes, math is obviously better than mosaics.
Precisely. Sketch built a dedicated vector tool specifically tailored for user interface design. It was a total revolution. But by 2018, the cracks in the Sketch workflow were expanding into massive fissures.
Yeah.
And the author outlines these specific grievances in the text with incredible precision.
The very first grievance they point out feels almost prehistoric today. It was the paper-computer pricing model. Let's really analyze what that meant for a creative professional in 2018. You weren't just buying access to a digital tool. You were literally shackling your creative output to a physical piece of hardware.
It was a hardware lock-in. And it was compounded by the fact that Sketch was famously exclusively built for the Mac operating system.
Right. No Windows version at all.
None. It relied heavily on Apple's proprietary core rendering technologies. So if you were a designer, you didn't just need a software license, you needed an expensive Mac.
Yeah.
And if you needed to work at the office and at home, you needed 2 maps and 2 separate licenses.
But let me play devil's advocate here for a second. Paying for software per machine was the standard for decades, right? Like Microsoft Office did it, Adobe did it. Was it really that uniquely stifling for designers, or is the author just complaining about an industry norm?
What's fascinating here is how the physical limitations of the hardware, being Mac-specific, the paper-computer model, how that directly constrained digital creativity and teamwork. Well, it was stifling specifically because of the nature of the work. Design is rarely a strict 9 to 5, sitting at one desk kind of activity.
That's true.
Inspiration or, a massive client emergency, it doesn't wait until you are physically sitting in front of the specific aluminum tower you paid a license for. If an idea struck you at a coffee shop and you only had your personal laptop without a Sketch license on it, you were entirely blocked.
You couldn't even open the file.
Exactly.
Yeah.
The physical limitations of the hardware directly constrained the digital flexibility of the worker.
It effectively killed any concept of remote flexibility. But the author's critique goes much deeper than just the pricing model. They move on to describe how the broader workflow ecosystem became, and I quote from the text here, annoying.
Annoying is putting it mildly.
Right. They point out that absolutely essential parts of the job like prototyping, gathering comments, developer handoff, they required entirely separate third-party services.
To understand why this was so detrimental, we really have to define what a modern designer actually does. Drawing the rectangles, picking the typography, establishing the visual hierarchy, the visual design phase, that is only step 1.
Just the tip of the iceberg.
Right. Step 2 is prototyping, linking those static screens together so stakeholders can actually tap a button and see how the app transitions, feeling out the user experience.
Yeah.
Step 3 is gathering and implementing feedback on those prototypes. And step 4 is handoff, delivering the final files to software engineers so they can inspect the precise code values, the exact hex colors, the pixel margins, just to build the real thing.
And according to the author, in the Sketch era, none of those steps, literally the bulk of the collaborative process, happened inside Sketch itself.
That is the core of the grievance right there. Sketch was an isolated island. You would craft your beautiful vector screens on this island, but to make a clickable prototype, you had to export your screens and use a plugin to push them across the ocean to a completely separate web platform.
Most commonly a tool called InVision, right?
Yes, InVision.
So you are taking these perfect, scalable, math-based vectors, flattening them into static image files, and uploading them to a completely different company's server just to draw invisible, clickable hotspots over the buttons.
Yes. And then the stakeholders, your clients or product managers, they would log into InVision, not Sketch, to leave their feedback. They would drop a comment pin on a specific screen.
So the feedback isn't even in your design file.
Nope. Meanwhile, your developers couldn't use InVision to get their code. They needed yet another specialized tool, something like Zeppelin.
Oh man, Zeppelin.
Zeppelin was a code inspection application.
Yeah.
You would have to sync your Sketch file to Zeppelin so the engineers could click on a button and see that it had a border radius of 4 pixels and a drop shadow of 10%.
I am having a visceral reaction just hearing that workflow described aloud. It sounds exactly like trying to write a complex novel with a team of co-authors by emailing a massive Microsoft Word document back and forth.
Oh.
Like completely relying on everyone to remember to hit Save As, append their initials to the file name, and just crying nobody edits the wrong version. Imagine the mental gymnastics required just to change a typo.
Let's follow that scenario.
Yeah.
Say a client leaves a comment in InVision saying, make this logo bigger.
Okay.
As a designer, you have to read that on the web, mentally map that specific screen back to the massive sprawling Sketch file on your hard drive, locate the artboard, resize the logo, manually re-export the file,
wait
wait for the plugin to sync back to InVision to resolve the comment, and then initiate a second sync to push that exact same change to Zeppelin so that the developers have the updated assets.
It is a logistical nightmare disguised as a creative process. Like, how does that level of friction impact the actual brain of a designer, especially a beginner trying to learn the ropes?
We refer to this in cognitive science as extraneous cognitive load.
Yeah.
Your brain has a finite amount of working memory. Think of it like RAM in a computer.
Okay, RAM.
When you are designing, you want all of your mental RAM dedicated to solving the user experience problem. Is this navigation intuitive? Does this color palette evoke the right emotion?
Right, the actual design work.
But in the legacy workflow, a massive percentage of your mental RAM was hijacked just to manage the tools. When the cognitive load of managing the software ecosystem outweighs the cognitive load of the actual design work, creativity utterly flatlines.
You just stop caring.
You stop taking risks because the logistical penalty for making a mistake and having to resync everything is just too high.
The author gives a perfect, harrowing example of this exact tool friction. They mention that they and a colleague were working on a large project, and they literally had to split the master design file into multiple smaller files so they could work on them independently.
Because of the overwriting issue.
Exactly. Because if they both opened the exact same file on the company server, whoever hit Save Last would permanently overwrite and destroy the other person's entire day of work.
It is the ultimate paradox. The goal of the software is to build a cohesive product, but the architecture of the software forces you to shatter the project into pieces just to avoid catastrophic data loss. You are artificially partitioning your creativity to accommodate a technical limitation.
Think about what that does to collaboration. Collaboration meant actively staying out of each other's way. You had to schedule who was allowed to touch the checkout screen file between 2:00 p.m. and 4:00 p.m.
And the chaos didn't stop there. The author goes into detail about the absolute terror of working across multiple Macs, specifically regarding the fragility of third-party plugins.
Oh, the plugins.
Because Sketch relied so heavily on external developers to build essential features, your workflow was entirely at the mercy of plugin versions.
I want to dig into the mechanics of that. Why does a plugin version cause such a severe breakdown?
Well, let's say you had a plugin that managed your color library. On your Office Mac, that plugin auto-updated to version 2.1, which fundamentally changed how it structured data.
Okay, makes sense.
You work all day, save your file, and go home. That night, you open your personal laptop, which still has version 2.0 of the plugin. When you open that file, the older plugin cannot interpret the new data structure.
Oh no.
Entire color palettes would just vanish. Text styles would revert to default. Hours of meticulous work could be visually destroyed simply because your secondary computer hadn't run a background update.
The author explicitly notes the constant lingering anxiety of having to, quote, remember to save and close files before switching to a different computer. And on top of that, having to manually store those massive files in a cloud drive like Dropbox or Google Drive.
Just watching the little sync icon spin.
Watching it spin and praying your internet doesn't drop before the upload finishes.
Which brings us back to cognitive load. The designer is no longer a creative problem solver. They are a defensive file manager. They are constantly playing defense against their own toolkit.
If you are an emerging designer listening to this, and your entire experience so far has been working in real-time, multiplayer cloud environments, this history might sound absurd, like totally made up.
It really does.
But understanding these historical bottlenecks is arguably the most crucial step in your education. It answers the why. Why does Figma have a centralized component system? Why does it have built-in commenting? You aren't just memorizing features, you are inheriting the hard-won solutions to a decade of intense, industry-wide suffering.
It creates a sense of intentionality in your work. When you understand the profound pain of overwritten files, you never take the centralized nature of a modern file for granted. You begin to leverage the architecture rather than just merely using it.
So we have clearly established the pain, the ecosystem was fragmented, the hardware was restrictive, and the friction was just crushing. This logically leads to the author's search for an alternative. But what the introduction of this book reveals, and this is a psychological phenomenon that is so relatable for anyone learning complex new skills, is that adopting new technology is rarely a sudden epiphany. It is almost never an overnight switch.
We love the narrative of this sudden technological breakthrough, But the reality of professional adoption is usually a slow, hesitant, highly skeptical progression.
Yeah, totally.
Professionals are inherently risk-averse when it comes to their core toolset, and the author provides an incredibly transparent timeline of this internal tug of war.
Let's analyze that timeline because it completely reframes how we should think about learning curves. It starts way back in March 2016. The author manages to score an invite to the Figma closed beta.
An exclusive club back then.
Very exclusive. They open it up, they play with it for roughly half an hour, and what is their verdict? They note that the concept of it working in a browser was impressive, but the app itself was too rough and buggy overall, so they just close the tab and walk away.
And I want to emphasize how completely rational that reaction was. We touched on this earlier, but we really need to dive deeper into why doing this in a browser was considered science fiction.
Please do.
The entire architecture of the World Wide Web, the Document Object Model, or DOM, it was designed to display text and simple images. It was built for documents.
Right.
It was never designed to handle the intense, hardware-accelerated rendering required for thousands of complex vector shapes operating simultaneously.
It's like trying to use a toaster to cook a 5-course Thanksgiving dinner. The foundational architecture just wasn't meant for it.
Exactly. The engineering leap that made Figma possible was moving away from the DOM and utilizing WebGL Web Graphics Library.
Okay, WebGL.
WebGL essentially allowed the browser to bypass the standard web rendering rules and talk directly to the computer's graphics processing unit, the GPU. It turned the browser window into a completely blank, high-performance canvas where Figma could draw every single pixel from scratch at 60 frames per second. Furthermore, to solve the collaboration issue, that overwriting nightmare we discussed, they had to implement complex computer science concepts, like CRDTs, conflict-free replicated data types.
That sounds intense.
It is. It allows multiple people to edit the exact same data structure simultaneously without ever creating a conflict.
Okay, so from an engineering standpoint, it's an absolute marvel. But from a user's perspective, sitting at a desk in 2016 with a deadline looming, none of that invisible math matters. The perceived fragility is all you see. You think, if my Wi-Fi drops for 10 seconds, does my entire career just evaporate into the ether?
Precisely. This is the classic chasm of software adoption. Recognizing that a new tool is technologically advanced, or even recognizing that it represents the future, is vastly different from betting your upcoming paycheck on it.
Yeah, paying the rent comes first.
The perceived risk of migrating a professional workflow learning entirely new keyboard shortcuts, testing how a new tool handles complex file exports, trusting an unproven cloud infrastructure with sensitive client data, it still vastly outweighed the immense daily friction of their existing Sketch workflow. They preferred the devil they knew.
The devil you know at least pays the bills. So the author abandons the beta, but the timeline continues. A year later, in 2017, they decide to give it another look.
Round 2.
Right. They explicitly note that they were thoroughly impressed by the progress and that the entire experience felt much more polished, but then they deliver the kicker. Still, I wasn't ready to use it for my work.
They are inching toward the precipice, but absolutely refusing to jump. And this highlights a crucial aspect of human psychology, the power of muscle memory.
And muscle memory, yeah.
When you use a piece of software for thousands of hours, the interface literally disappears. You don't think about clicking a button, your fingers simply execute a macro. Moving to a new tool, even a superior one, strips you of that fluency.
You feel like a beginner again?
You are suddenly a beginner again. You are clumsy. Things that used to take 5 seconds now take 5 minutes because you are hunting through menus. For a professional, that temporary loss of speed is terrifying. It feels like incompetence.
Here's where it gets really interesting, because the author didn't just casually switch, they manufactured a breakthrough. You don't just wake up one morning and decide to embrace incompetence, right?
Right.
The author details this breakthrough in 2018. They mentioned that during this period of hesitation, they had been occasionally using Figma for what they call random illustrations. They were doing low-stakes work, doodles. Personal projects where if the browser crashed or the export failed, absolutely nothing was at risk.
That concept of low-stakes experimentation is the secret mechanism of adoption. You cannot force a professional to learn a new complex system under the intense pressure of a deadline. The stress response actively inhibits learning.
It just shuts you down.
But play is how the brain builds new neural pathways without triggering the fight-or-flight response. By doing random illustrations, the author was slowly, incrementally building the necessary muscle memory in a stress-free environment. They were getting familiar with the temperature of the water before diving in.
But at a certain point, playing in the shallows only gets you so far. You have to learn how to swim in the deep end. The author describes the definitive tipping point. After realizing they were enjoying the process more and more during these low-stakes sessions, They took a massive leap.
A huge leap.
They took all of their sketch files, dozens of complex screens for an active, highly important current project, imported them entirely into Figma, and as they bluntly put it, committed to making it work. They essentially burned the ships on the shoreline so they couldn't retreat.
They manufactured a scenario where failure was no longer an option. The transition from random illustrations to importing dozens of screens for a live project is the exact moment adoption crystallizes. They recognized that the slow trickle of casual play would never force them to truly master the advanced features or fully leverage the collaborative power of the tool. To reap the long-term benefits of a frictionless workflow, they had to intentionally subject themselves to the acute, temporary pain of fully switching. They had to push through the barrier of feeling slow.
If you are an emerging designer, this historical anecdote is perhaps the most validating thing you will hear all week. When you sit down to learn a sprawling new design system or a complex piece of 3D modeling software or a new prototyping logic, it is entirely normal if you feel completely alienated.
It's totally fine.
You might poke around for 30 minutes, feel a wave of frustration, and immediately close the app. That isn't failure. The industry's top professionals, the people writing literal masterclasses on this software experience, that exact same rejection.
Everyone goes through it.
The strategy is to allow yourself to retreat, but to keep returning with low-stakes projects. Keep doodling until you build the confidence to import your professional life over.
Exactly. Forgiving yourself for that initial hesitation is a mandatory part of the learning cycle. You aren't failing to learn, you are subconsciously evaluating risk. Once you neutralize the risk through play, the mastery can actually begin.
So the author has finally crossed the chasm. The year is 2018, the ships are burned, and they are fully committed to the browser-based future. Naturally, as any dedicated professional does when they adopt a new primary instrument, they actively seek out resources to master it.
Right, they look for a guide.
They look for the user manual, but what they found in the educational landscape of 2018 was severely lacking. And that exact frustration is what birthed the book we are dissecting today. This brings us to a fascinating discussion about who this book was written for and the specific, highly intentional philosophy behind how it was structured.
The author is incredibly precise about their target audience right from the opening paragraphs. They observed a distinct pattern. Most people opening Figma for the first time fall into one of two very different camps.
Okay, what are the camps?
Camp 1 consists of professionals switching from Sketch, undergoing the exact same reluctant transition the author just survived. Camp 2 consists of people who are entirely new to UI design, opening their very first vector graphics tool ever.
Those are two radically different starting lines. One group brings an entire encyclopedia of pre-existing knowledge, but they have to actively unlearn deeply ingrained habits and figure out how their old workflow maps to this new cloud-based interface.
It's a lot of unlearning.
And the other group is staring at a blank canvas trying to understand what the word vector even means. How does an author possibly write a single book that caters to both extremes without completely alienating one of them?
By establishing an incredibly rigid scope. The author makes a defining, almost ruthless statement about the limitations of their teaching. They state explicitly, this book won't teach you design and focuses only on the app.
Just the app.
They draw a definitive line in the sand. They are refusing to teach the subjective artistry of design. They won't cover color theory psychology or typographic hierarchy or how to conduct user research.
It's a highly pragmatic approach. They are basically saying, I am not here to teach you how to be an architect. I am here to teach you exactly how this specific hammer and these specific nails work. Though, to be fair, they do include a slight caveat, noting that where appropriate, I try to discuss fundamentals and best practices.
Which is a necessary concession, really. You cannot explain how the auto layout feature works without inevitably touching upon the fundamental design concepts of padding, margins, and responsive spatial relationships.
True, they're intertwined.
But the relentless focus remains on the mechanics of the software itself. The stated goal, etched right there in the text, is to help the reader design efficiently and achieve mastery of the tool.
And this leads us to the core motivation behind the book. In 2018, when the author was searching for educational materials, they knew exactly what they wanted. They wanted a short and concise manual that I could read in a couple of evenings.
But the educational market had shifted completely away from that format. The author notes that their search yielded only two extremes: basic, superficial blog post introductions that barely scratch the surface, or massive, protracted, multi-hour video courses that required a huge time commitment.
There was no middle ground.
Exactly, a glaring void. There was no dense, actionable, high signal-to-noise ratio resource for a professional who just wanted the unvarnished mechanics without all the fluff.
Which prompts one of the most striking quotes in the entire introduction. The author declares, "Nothing beats a good manual for me. There is just something special in compressing all the knowledge about the topic or a tool into one book. When done well, the manual can be an elixir of mastery."
An elixir of mastery.
That is a massive, incredibly bold claim to make about a written book.
If we connect this to the bigger picture, it reveals a profound understanding of cognitive psychology and the mechanics of deep learning. The author is actively rebelling against the modern trend of passive, bloated educational content.
I want to stop and push back on this premise really hard because it feels a bit contrarian to me. We live in the golden age of high-definition, screen-recorded YouTube tutorials.
We do.
You can watch a master designer build an entire complex application interface in real time, in 4K resolution. You can literally pause the video, rewind it, and see exactly where their cursor moves, what menus they open, and what keyboard shortcuts they press. It is a one-to-one visual replication of the task. So is a written manual like static text and a few screenshots on a page actually is a superior way for a beginner to learn highly visual interactive software? Doesn't video just logically make more sense?
It seems like it should, yes. But if we dive into the neuroscience of learning and retention, the author's preference for text makes total sense. Video courses suffer from a widespread psychological phenomenon known as the illusion of competence.
The illusion of competence. Break that down for me.
When you watch a high-quality video tutorial, you are engaging in a highly passive experience. The instructor dictates the pace. They have already solved the problem, smoothed out the errors, and perfectly choreographed the workflow.
It looks flawless.
Exactly. As you watch them effortlessly manipulate the software, the mirror neurons in your brain fire. You begin to mentally simulate their actions. Your brain absorbs their success, and you are flooded with a sense of understanding. You think, yes, this makes perfect sense. I completely know how to do this.
Right. It's the exact same feeling you get when you watch a Michelin star chef on a cooking show perfectly dice an onion at lightning speed. You sit on your couch and think, I totally understand the technique. I could absolutely do that.
Yes.
And then you walk into your kitchen, grab a knife, and immediately realize you have zero actual motor control, and you're probably going to lose a finger.
That is the perfect analogy. You mistook the recognition of a skill for the possession of that skill. You watch the chef execute the motor functions, but you didn't build the neural pathways required to execute them yourself.
That makes so much sense.
Video tutorials frequently breed this illusion. You sit back, absorb the content, feel competent, but when you open the software, you are completely lost.
So how does a written manual solve the illusion of competence? How is reading text any different?
Because text inherently introduces friction. And in learning, friction is a feature, not a bug.
Friction as a feature, I like that.
A concise, written manual forces a fundamentally different relationship with the material. When you read a concept described in text, let's say, instructions on how to build a responsive button component, you have to cognitively process those words, internalize the abstract concept, and then actively translate that text into physical actions inside the software yourself. The manual provides the map, but it forces you to walk the terrain.
You cannot passively consume a manual and feel like you accomplished something. You read a paragraph, and then you are forced to look at your screen and actually do the work to understand what you just read.
Furthermore, the reader dictates the pace. If a concept is confusing, your eyes naturally reread the sentence. You pause, you experiment in the software, and you return to the text.
At your own speed.
Right. With video, the timeline keeps moving. If you get confused, you have to scrub back and forth trying to find the exact timestamp where the instructor clicked a hidden menu, which breaks your concentration. For a dedicated learner, compressing knowledge into text strips away the passive entertainment factor. It demands active cognitive translation, which is the biological prerequisite for building long-term memory and achieving raw mastery.
A video is a movie you watch, a manual is a puzzle you are forced to solve. And that intentionality, that intense focus on active, friction-based learning, perfectly sets up the final and, frankly, most surprising revelation in this introduction.
Scope cuts.
Exactly. If this book is meant to be the definitive elixir of mastery, why did the author intentionally, explicitly leave massive core features of the software entirely out of the book?
This is where we transition from the philosophy of learning to the absolute necessity of scope. True mastery is rarely achieved by trying to consume every available piece of information simultaneously. Mastery requires deep understanding within strict constraints.
Right.
And the author's refreshingly transparent about what they chose to exclude to enforce those constraints.
They lay it right out there in the text. They state that to keep the book reasonably short and focused, they concentrated exclusively on the core visual design process. And they explicitly announce that they are ignoring two massive areas of modern interface design: prototyping and animations.
To a modern designer operating today, that exclusion might sound almost heretical. Prototyping, the ability to link screens together and test user flows and animation, the micro-interactions that make an interface feel alive, they are arguably what make modern tools like Figma so dominant.
Yeah, they're huge selling points.
To write a masterclass and omit them seems like leaving the engine out of a manual on how to build a car. But the author doesn't just arbitrarily drop them. They provide three highly analytical, historically contextualized reasons for these exclusions.
Let's dissect those three reasons, because they offer an absolute masterclass in how you, the listener, should prioritize your own educational roadmap. Reason number one from the text. The author states that prototyping and animations are simply not as universally used as the design tools.
This highlights a fundamental truth about the hierarchy of digital production. Every single digital product on Earth, whether it's a complex banking application or a simple landing page, requires core visual design.
Layouts, typography grids, spacing rules.
Exactly, and color contrast. That is the absolute non-negotiable foundation of the discipline. However, not every single project necessitates complex, interactive prototyping or intricate microanimations within the design file itself.
A lot of times you just need flat screens.
Right. Sometimes a series of flat, perfectly aligned screens is entirely sufficient for the engineering team to begin their work. Therefore, teaching the core visual tools serves 100% of the audience 100% of the time. Teaching advanced prototyping might only serve a subset of that audience for very specific specialized tasks.
It's focusing on the universal base layer first. Okay, reason number two for the exclusion. The author notes that prototyping and animations often require external tools or services. Now, we need to apply some historical context here, right?
Yes, very important context.
This was written reflecting on the state of the industry around 2018. While Figma possesses incredibly robust native prototyping capabilities today, back then, relying on external logic engines or complex, specialized animation software like Principle or After Effects was still standard practice.
And this touches on the danger of breaking the learning loop. If an author writes a manual that heavily relies on third-party external tools to accomplish a task, they are introducing volatile variables into their curriculum.
Like dependencies.
Exactly. What happens if that external animation tool fundamentally changes its interface 6 months after the book is published? What if the company goes out of business? The manual is instantly obsolete. By strictly restricting the scope of the book to the core application's native foundational design process, the knowledge becomes evergreen. The foundational principles of vector manipulation and layout do not change, ensuring the manual remains reliable year after year.
And reason number three perfectly loops back into our previous debate about text versus video. The author bluntly, honestly states that prototyping and animations are simply not easy to explain in a written form.
This is a tremendous, necessary display of self-awareness from the author regarding the limitations of their chosen medium.
It really is.
Try to imagine explaining the intricate nuances of a Bezier animation curve, describing exactly how an element should slowly accelerate, reach peak velocity, and then gently ease into a resting state over the course of exactly 300 milliseconds.
It's impossible. You'd spend 3 pages describing a visual effect that takes half a second to watch.
Exactly. Using static text and static screenshots to teach complex, time-based interactivity is a guaranteed recipe for intense reader frustration. It is the one specific area where the passive nature of video or deeply interactive code-based mediums truly is vastly superior to a book.
You just have to see it move.
Right. By recognizing and respecting the limitations of the written word, the author ensures that the material that is included in the book is taught exceptionally well, rather than attempting to teach absolutely everything and doing it poorly. The author does note that covering these interactive topics in the future is still up in the air, leaving the door open, but for this specific foundational manual, the boundary is firmly drawn.
So what does this all mean? Like for you, the listener who might be feeling overwhelmed staring at a complex software interface today, I believe this author's approach offers an incredible sense of relief. It is the ultimate professional permission slip to realize you do not have to learn everything all at once.
This raises an important question about how we must manage cognitive load for beginners.
Tell me more.
Well, when you open a modern design tool today, the interface is an intimidating cockpit, packed with dense panels for local variables, Boolean logic, auto layout behaviors, interactive component variants, and complex conditional prototyping triggers. It is objectively terrifying.
It's a lot of buttons.
But here's an author, someone with the authority to write a literal masterclass, telling you that you can achieve a massive, highly respected level of mastery by intentionally ignoring all the flashy interactive stuff and focusing relentlessly on the absolute core static design process first.
If a junior designer attempts to learn foundational grid systems, complex typography rules, and intricate interactive animation states simultaneously, their mental RAM will completely overflow.
They will master absolutely none of it. They will become paralyzed by the sheer volume of variables. By ruthlessly stripping away animations and prototyping, the author is forcing the reader into a confined space where they must master the foundational building blocks.
It's the culinary equivalent of mastering basic knife skills. You don't walk into a kitchen on day one and try to execute a complex molecular gastronomy foam utilizing liquid nitrogen.
Definitely not.
You stand at a cutting board and you learn how to hold a knife. You learn how to dice a carrot consistently, safely, and efficiently. You do it hundreds of times until the knife feels like an extension of your arm. Only when that foundational motor skill is deeply ingrained, requiring zero conscious thought, do you move on to complex recipes.
That is exactly it. Constraint breeds true mastery. Once you can effortlessly manipulate vectors, align shapes, and construct precise layouts without actively thinking about the software interface, adding the complex layers of interactivity and animation later becomes exponentially easier.
Because your brain has the space for it.
Right, because you aren't fighting the core tool anymore. Your cognitive load is freed up entirely to focus on the logic of the animation, rather than struggling to figure out how to draw the shapes you are trying to animate.
And that beautifully brings our entire exploration of this introduction full circle. If we step back and look at the massive landscape we've traversed today, we see a truly fascinating, deeply human narrative arc of technological evolution.
We really do.
We didn't just look at software features, we started in the trenches, the fragmented, intensely frustrating days of legacy, localized desktop design tools. We examined the genuine professional anxiety of paper computer constraints, hardware lock-in, and the terrifying friction of disconnected third-party workflows where collaboration meant actively avoiding your teammates to prevent catastrophic data loss.
We explored the psychology of navigating the chasm of adoption. We looked at why regional professionals reject the future when it looks fragile, why browser-based rendering was viewed with such intense skepticism, and the vital importance of low-stakes experimentation in building the confidence necessary to finally cross that chasm and commit to a superior workflow.
And finally, we arrived at the creation of the solution, a highly focused, deliberately constrained, concise written manual. A resource forged in the fires of that historical frustration, built not to overwhelm the beginner with endless video content, but to provide a friction-based, active, highly efficient path to raw mastery by intentionally leaving the flashy, complex extras behind.
It is a profound evolution. Understanding this history, understanding the why behind the tools, transforms you from a passive user into a deeply intentional practitioner of design.
If you are at the beginning of your journey, or even if you are a veteran looking to strip away bad habits and experience this intense, active learning process for yourself, you absolutely have to check out the foundational text we've been unpacking today. The book is called Designing in Figma, a masterclass in modern interface design. It is the precise, focused blueprint you need to cut through the modern noise and lock down the absolute fundamentals.
It is genuinely an essential read for building that frictionless cognitive foundation we've been discussing.
And if you want to keep leveling up, make sure to follow us for more technical design breakdowns and career-building content. We are going to keep clearing the path and decoding the industry for you.
But before we sign off, I'd like to leave you with one final provocative thought to mull over. We talked extensively about how the author first encountered Figma in its closed beta in 2016. They looked at a tool that was running in a browser, deemed it impressive but rough, decided it was too fragile for real work, and walked away.
Yep.
Yet that rough, fragile beta completely revolutionized the entire global design industry in just a few short years. It entirely replaced the dominant, entrenched software of its era and rewrote the fundamental rules of how humans collaborate digitally.
It proved that the science fiction gimmick was actually the inevitable future.
Exactly. So as you continue to build your career and hone your skills today, I want you to look around at the absolute fringes of the tech industry right now. What hidden, seemingly fragile, rough, but impressive technology is currently sitting in a closed beta? What new paradigm, perhaps generative AI, spatial computing, or node-based logic, is currently being dismissed by seasoned professionals as a mere toy or an unreliable gimmick, just waiting to completely upend your entire design workflow tomorrow?
That is the exact question you must always be asking if you want to stay ahead, because the definitive blueprint is never truly finished. The ink just keeps drying on a brand new medium. Keep exploring, keep questioning the tools you use, and we will catch you on the next deep dive.